Today, pre-painted products are all around us, beautiful, durable, and environmentally friendly. The list of industries depending on pre-painted metal grows and grows, from its humble beginnings in the Venetian blind market to the diverse applications used today. For example, construction materials, including cool metal roofing, corrugated and composite wall sections, rainwear, fencing, and even doors and shutters. Pre-paint has become the standard for appliance manufacturing, including heating, ventilation and air conditioning, HVAC, laundry and refrigeration, cookers and small electronic appliances. Pre-painted metal supports the transportation industry, providing material for vehicle bodies, truck trailers and cabs, filters, and various underhood components. Packaging applications use pre-painted metal to contain liquids and other substances, including can ends and bodies and drums. Pre-paint is used in many other applications as well, including shelving, metal furniture, lighting fixtures, electrical boxes. So what is pre-paint, and how do you know if it's right for you? Pre-painting is the process of applying coatings or paint to metal substrate on a continuous coil coating line. On a modern coil coating line, the flat metal is pulled at speeds of up to 800 feet per minute through the continuous coil line processes, including cleaning, pre-treatment, prime coat, curing, finish coat, cooling, and finally rewinding. The processes of cleaning and pre-treating the metal by chemical conversion are critical steps that make the surface free of imperfections and suitable for maximum primer adhesion and corrosion protection. Primer is applied evenly, edge to edge, on one or both sides of the strip, cured in a gas-fired oven and cooled. Modern primers are based on polyester, polyurethane, and acrylic waterborne chemistries, and are used to provide maximum adhesion of the top coat. The top coat is applied over the primer, oven cured, and the strip is cooled to room temperature. At the end of the line, the coated metal is rewound and wrapped for shipping. There are three primary reasons for applying a coating: color, appearance, and protection. With pre-paint, virtually any paint color can be achieved. How does paint get its color? With pigment. Pigments are added to solvents and other materials to create color. Each pigment has a unique color, and when combined can create the exact color desired. There are even specialized pigments that reflect infrared light and give us the cool roof coatings that are gaining in popularity. To ensure colors are consistent, every coated metal coil is verified by comparing the painted metal strip to the color standard on record. The second reason to apply coatings is appearance. The highly adaptable coil coating process provides manufacturers with an array of unique finishes. Metal can be embossed after coating, right in line. Pre-paint is available in a wide variety of gloss ranges and specialty coatings, including antimicrobial, non-skid, fingerprint resistant, and anti-static, can be specified without adding a step to the manufacturing process. Pre-painted metal resists corrosion, even on cut edges. In fact, field tests of pre-painted air conditioning units proved this. A study showed pre-painted parts were repeatedly and significantly better than post-painted parts in terms of the corrosion resistance. That's because pre-paint virtually eliminates edge-to-edge and side-to-side variability. For more cut-edge corrosion performance information, please visit the NCCA website and download the tutorial Cut Edge. Pre-paint is tougher than you think. So how do you know what type of paint you should order? In coil coating or pre-painting, there are 8 primary coating chemistries. These are acrylics, epoxies, polyesters, siliconized polyesters, fluorocarbons, plastisols, urethanes, and acrylic waterborne. Each technology has a unique combination of appearance, formability, durability, and cost. It is always best to have a coil coater, service center, or paint supplier help you determine the final specification. But the NCCA has gathered some information on the various types of coatings and their typical end uses. Acrylic coatings are based on acrylic and melamine chemistry. The characteristics of acrylic coatings are their exceptional flow and film clarity, surface hardness, and dirt and stain resistance. They are available in single and two-coat systems. The acrylic's hardness and ability to accept ink printing and silk screening makes these coatings ideal for transportation units and signs. Epoxy coatings are based on epoxy resin chemistry. Characteristics of epoxy coatings include excellent adhesion, chemical resistance, surface hardness, recoatability, and bondability, making them excellent candidates for primers and backers. Epoxy coatings are commonly found on insulated garage doors, HVAC, and appliance items. Polyester coatings are based on polyester and melamine chemistry. Polyester is the most versatile coating technology. The coatings are cost-effective, available in single or two-coat systems, are flexible, and can offer good weathering characteristics. Applications include residential and commercial building products, garage and entry doors, appliances, lighting, office furniture, and HVAC. By modifying a polyester resin with silicone and cross-linking this resin with melamine chemistry, a siliconized polyester coating is formed. This coating is formulated for good weathering properties and improved resistance to chalk and fade. Common uses include commercial building panels and roofs. Fluorocarbon coatings are based on PVDF and acrylic resin chemistry, and characteristics include an exceptional resistance to aggressive weather environments, chemicals, dirt, and stains. These coatings are used for automotive trim applications and high-quality building products. PVDF coatings, as well as siliconized polyester coatings, are the two most formulated chemistries with cool pigments for increased environmental building compliance and energy efficiency. Plastisol coatings are based on PVC resins and plasticizer chemistries. They are known for their exceptional flexibility and can be applied to provide a smooth or striated finish. They are also chemical resistant and require a primer. Plastisol coatings provide a thick coating that protects against hail and other severe weather, making them ideal for residential trim and siding. Urethane coatings are based on polyester resin and polyisocyanate chemistry. Urethane coatings are flexible and resistant to post-bend fracture. They're the preferred chemistry for use as high-performance primers because of their excellent adhesion to metal substrates. Last, acrylic waterborne coatings are based on acrylic emulsions. Acrylic waterborne coatings have a low solvent content and use water for reduction and initial cleanup. The exterior systems require a primer, and the coating offers excellent color and gloss retention. Acrylic waterborne coatings can be used on coating lines that cannot handle higher VOC compounds and are most commonly used for residential building products, building panels, and specialty items. Once you have selected your coating and are sure you have the right spec for your end use, how do you know the coating will perform the same time after time? Every coated coil is subjected to standardized testing to confirm color, gloss, adhesion to substrate, flexibility, and more. It's important that colors are consistent across the width of the strip, as well as between coils of an order. Colors are confirmed with a spectrophotometer, providing the advantage of standardizing the evaluations. Gloss, or the degree to which a surface reflects light, is measured with a gloss meter at different angles. The gloss meter illuminates the surface of the coating at specific angles to confirm coating gloss is within a set range. In order to confirm adhesion of a coating to the metal substrate, T-bends and reverse impact tests are conducted. In the T-bend test, the metal is bent in a vise to simulate a forming bend and is inspected for cracking. Scotch 610 tape is applied to the bend, pulled off, and inspected for any paint pull-off. To simulate an impact, the back of the sample is struck to create a bump. Tape is applied to the bump and removed to determine adhesion. Coil coating is also an environmentally friendly process because the VOCs in the paint are used to heat the coil coating curing ovens. And with emerging paint line technologies and continued research, PrePaint is getting even greener. Great news for the environment, and great news for manufacturers who sell globally. Do you export electronic equipment? If so, your products must meet the RoHS directive. Because pre-painted metal can be specified to meet the requirements set forth by RoHS, products can be easily designed, manufactured, proven compliant, and brought to market in the European Union and in countries with similar regulations. Learn more about RoHS by viewing the RoHS Directive tutorial on the NCCA website. An emerging technology called UV curing is gaining interest as another alternative to curing paint thermally. With UV curing, light rather than heat is used to transform the liquid paint into a solid. Advancements in UV curing technology have the potential to reduce VOCs, improve the carbon footprint, and increase environmental compliance. As you can see, PrePaint not only offers nearly every color under the sun, it's helping keep our planet green. You can learn more about the environmental benefits of PrePaint by visiting the NCCA website and downloading the Energy and Environmental Benefits PrePaint tutorial. PrePaint can help manufacturers achieve their bottom-line goals. Since it arrives ready for manufacture, PrePaint increases productivity by eliminating paint line bottlenecks and reduces work-in-process inventory. Manufacturers also save on expensive paint line equipment, materials, energy, and manpower. These resources and factory space are freed up for more profitable tasks or a safer workspace. And one last benefit. The coil coaters assume the environmental liability of the painting process, so maintenance of emissions, equipment, permits, and additional costs of compliance and waste are eliminated. Pre-painted metal saves cost, time, and hassles. Brought to you by the National Coil Coating Association. If you're ready for help in writing a pre-paint spec for your application, contact a coil coater or the National Coil Coating Association today. www.coilcoatinginstitute.org/supplier